So I'm going to place a mirror here and send rays in at various different angles. So what I want to do first of all is I'm going to draw in the angles I'm going to send the rays in. So I'm going to use one of the grids on the grid paper, the graph paper rather. So I'm just going to draw a line here, and I'm going to make this my normal, and I can draw that in just using the graph paper. So this is where I'm going to place my mirror. So that's the back of the mirror. So this is the mirror. And what I want to do now is I'm going to measure in some angles to measure to the normal to send my rays in. So there is the protractor. So that's going to be 10, 20, 30, 40, 50, 60, 70, and then 80. Okay, so those are my angles. This is the normal. And what I want to do now is just draw in those rays, those incident rays that are going to come in, so that we can then use the ray box to follow these lines and work out where they go when they hit the mirror. Okay, now we've set up our page, with each of these being our incident rays going in 10, 20, 30 all the way around. What we can now do is set up the ray box so we can send the rays in at those angles. So what I'm first going to do is going to put a couple of blanking plates, metal plates in here to stop the light leaking out the side. And then I'm going to put in this comb, which will make us a nice narrow ray. And so if I insert the comb, you can see a nice narrow ray coming. I could, if I was setting it up, put it closer here, but you can see it's quite a wide, unfocused ray. So by putting it here, I get a nice sharp shadow, so I get a nice distinct ray. I need to place my mirror on the point where I've drawn on the page. So there's the outline for the mirror. And now what I'm going to do is I'm going to send the rays in, and I'm going to make little marks for each reflection. So here's the incident ray coming in here, and here's the reflection, and I'm just going to work my way around until I've got all the way to 80 degrees. So I just put a little mark here. I can fill it in afterwards. I can draw in the reflected ray after I've completed it. So this is 30. You can see straight away that the reflected ray is almost coming out at the same angle as it enters. So we're hopeful that this will prove the law of reflection, that the angle of incidence is equal to the angle of reflection. Try and be as accurate as possible when you're sending your rays in, so that you'll get some good results. Try and be precise, so when you're sending your incident ray, make sure it's following the pencil line, like so, and then try and put a mark in a nice, neat mark on the other side. Okay, so we've now completed all our rays, and what we can now do is fill in the reflected rays on the sheet of paper. So I'm now going to take my ruler, and I'm going to draw in these reflected rays. So there's the first one coming out there, and then the next one. And I'm going to work my way all the way around until I've completed all the rays. Okay, and so I'm just going to fill in the last one. This is the reflected ray from the 80 degrees. And now what I need to do is measure in these angles for these reflected rays. So there's the rays coming back off the mirror, which was here, and what I want to do now is measure these angles. So I place a protractor here. In fact, let's do it on that. Okay, so we measure our angles to the normal, remember. So this one is 10 degrees, so it came in at 10, it's come out at 10. The next one is 20, 30, 40, 50. Slightly off on that one, probably just a bit inaccurate, but that was 61 degrees, 70 degrees, and then 80 degrees. So you can see fairly convincing proof there that the angle of incident coming in is equal to the angle of reflection coming out. So we've proven the law of reflection, that the angle of incidence is equal to the angle of reflection.